Nancy, thank you for the nice introduction, and thank you for inviting me. It's a pleasure here. Thank you. So, I don't know what happened to the background. It's supposed to be gold, right? Black and gold is our Also, I want to explain a little bit about my affiliation, as you can see here. Okay, School of Mechanical Engineering and also Division of Environmental and Ecological Engineering. Okay, that division is an independent unit under College of Engineering. It's not part of the School of Mechanical Engineering. Okay, Purdue system is kind of complicated. Under a college, we could have a division, a department, and a school. But I still need to figure out, what's the major difference. And I heard it's about, well, what kind of degree you can offer. As a division, we started back in 2007. We can only offer bachelor degree now. Okay, that's why it's called division, I think. But anyway, the purpose of this division is to bring faculty from different schools and departments that are interested in environmental sustainability issue. And we try to work together to solve the problem at the root. So instead of traditional, say, environmental engineering folks, they try to do nothing against them, okay? They do remediation of the annual pipe approach, and we are trying to move upstream, okay? Say, sustainable design and how to do improve manufacturing process, right? So that's the focus, the reason we started that new division. So today, the focus apparently is on LCD, right? Could be monitor, could be TV. And this slide here shows the market share of different TV technology. And apparently, today on market, we have many different technologies, right? The oldest one is the CRT, right? As you can see here, okay, it used to dominate the market, right? But as of right now, okay, we see the LED backlight LCD monitor or TV, they are dominating, right? And in the middle, okay, during that time period, we have the so-called cold cathode fluorescence lighting LCD display, okay? And so when did you get your first LCD TV or LCD monitor? I got mine, a small monitor, back in 2003. And my first LCD TV was back in 2007. Okay. And if you check, okay, the trend, and you can see as of right now, you can imagine we have lots of CRT monitors retired, right? They show up in the waste stream. But we are having problems here, right? And early this year, okay, on New York Times, okay, there's an article talking about CRT monitors. So basically, there's a recycler in California. They receive government incentive and subsidize, okay, for collecting the waste. And eventually, they couldn't figure out the profitable way to deal with the waste. So the owner just abandoned the warehouse. Because, okay, we know a large piece in the monitor is the tube, right? And we have lead there, right? It's leaded glass. And the amount of lead is continuing going down. So there's no market there. They cannot sell it. And that's why. So we know we have issues with CRT monitors. And next, as you can see here, we will have millions, well, hundreds of millions of LCD displays showing up in our waste stream in the next 3, 4, 5 years, right? And we don't want to see the same problem happen as in the case of CRT monitor, right? And that's why, okay, we start thinking about how to recycle LCD monitors and LCD TVs. And actually, back in 2011, we talked to a recycler outside of Chicago, and they told us, okay, recycling LCD in a cost-effective way, okay, that's a glaring industry need. And this is quite a complicated issue, right? And if you take apart LCD monitor, as you can see here, we have this kind of structure configuration, right? And front, you have a cover, a frame, right? And then you have basically the screen assembly. And there, you sandwich polymer layer, glass, ITO layer, and liquid crystal in the middle, and then, okay, another layer of ITO and glass and polymer, right? And then you have this film side as polarizer, right? And then all different kind of circuit boards, for signal processing and control, right? And then you have a microframe, okay, enclosing the screen assembly, and then, okay, the back cover, right? And apparently, due to EPA regulation, you cannot landfill electronics anymore in most of the states. And so basically, you have to recycle, take it apart, right? Try to recover either components or materials, right? And but for the LCD monitor TVs, okay, we have many issues. Okay, first, okay, what kind of value you can recover from a typical LCD monitor? Okay, so we talked to several recyclers, and for a small size, say 16-inch LCD monitor, we took it apart and we weighed the components and we talked to them and asked for what kind of like money or revenue, okay, these components can bring in, and they give us numbers like that. So basically, you can get about $6 by selling those material components. But keep in mind, okay, that estimate was based on the market condition back in later last year. At that time, okay, gold price was at peak, right? And the reason is the gold price will affect how much money you can get by selling circuit boards. And lots of recyclers actually, they collect and they ship all the waste circuit boards to Belgium. And Umicore, that's the name of the company, they process the boards and to recover precious metals. Okay, so given today's gold price, okay, likely you can only get less than $5 or even $4 out of the monitor, right? And check the labor rate and overhead. Okay, they told us, okay, it's in a wide range. Could be $20 per hour, could be $6 per hour. So basically, in order to make money, you need to do it really fast, right? So several minutes, you need to take one monitor completely. But back to the structure. Okay, we have the backlight in the middle, and the backlight contains mercury, right? So you don't want to break it, right? So threading is likely not an option because you break the light, the tube, and everything will get contaminated by mercury, right? So you don't want to do that. And then, okay, to do manual disassembly, okay, those tubes are hidden deep in the assembly. It really takes time to get there. And also, it's common for all the E-waste issue. You know, you receive all different kinds of, say, monitors, right, with different design. And even just try to open the case, the outer casing, could be very challenging. So we went to a recycler in Wisconsin, and the guy told us, okay, sometimes it's so frustrated to open the case, they just smash it on the ground. And certainly that will break the case, but also will break the die tube. That will get mercury out. So additional challenge, okay, is with the liquid crystal in the screen assembly. Okay, we only have 20, 30 milligram liquid crystal there, but there is health concern regarding this chemical. So especially monitors made before 2002, 2003, okay, if you landfill, okay, the liquid crystal could leach out and contaminate water. If you burn it, okay, PAH will come out. So, ideal case, you want to remove the liquid crystal before, okay, sending the glass and the polymer to the downstream facilities. Okay. So, how to do it? Remember, we want to do it really, really fast, right? So ideally, say 2 or 3 minutes. That's what our recyclers told us. Actually, they want 2.5. And they believe if we can achieve that, they can make a decent amount of money by recycling LCDs. Okay. Okay. First, we want to have the outer case open, right? And basically, it's just plastic, right? But the front cover and the back cover, usually they are snapped together, right? And you don't want to really apply large force to the structure because that will likely break the components inside, including the light tube, right? So first, we started with a power tool, the power screwdriver, and then we found out, okay, many times the screws actually, due to some reason, got stripped, and it's kind of difficult to get it out. And then, okay, we figure out maybe we design a new tool, something like this. So basically, in addition to the drill bit, okay, you add a cutter. So basically, you apply force, and if you think the screw is straight, you just push harder and engage the cutter. That will just cut the surrounding plastic through, and then, okay, you can take out the screw, right? So instead of trying to fight and take just the screw part, right? Okay, and this way, okay, you actually detach the front and back mechanically, but not 100%, right? We still have some snaps, right? And how to get on that? We have this kind of oscillating cutter. So instead of trying to use a screwdriver to pop open the case, we just cut the four edges. And as you can see here, that's the cutter, and this is a metal guide, and you put your monitor there. And it's called oscillating cutter because the cutter is not really rotating. Instead, it's doing something like this. Okay, you just push the monitor along the guide through, and that will cut open the outer piece. Okay, after that, okay, you have something like that, right? There's a microframe, And for this step, okay, we kind of find out, okay, the available tools can be used, and actually it's quite efficient. And we just use the common wire cutter and a power screwdriver, and then you see the microframe with circuit boards, and the other piece is the screen assembly. The mercury containing light tube, okay, they are either on the top or the bottom or both. And for a small LCD monitor, we may have 4 to 6 light tubes there, and they are small. And the diameter is 2 or 3 millimeters, something like that. So, how to detach the circuit board? That's the next task. Okay. Instead of trying to unscrew, we designed this kind of like a shearing tool, right? So basically, that's the edge of the circuit board. And then you can just use a hammer to drive through and cut this part off. And then you have your circuit board detached. And so basically, if you have 5 screws in the corner, okay, it probably will only take 10 seconds or something, right? And when we were running the test, we didn't use a powered hammer, so it could be a little bit painful, to keep many times. But if you have a power hammer, okay, that will make life much easier, right? So. Okay, next, the interesting piece. Now you have that screen assembly, this one. Okay, and remember, we want to take the mercury containing light tubes out, right? And first, we just pry open the casing. And for most monitors, this is not very difficult. But we did run into several old monitors built back in 2001, 2002. Okay, they have a very sturdy metal frame enclosing the unit. And for those kind of monitors, this will not work, and we don't really know how to do it, so we couldn't figure out. But for most monitors, okay, the microframe is not that strong, and you can certainly just use a pry tool. And after that, okay, you have the PMMA light guide. You have many film, okay, as polarizer, and then the actual screen. And this screen has at least 5 layers. Okay, a polymer layer on top, and then beneath is the glass, then the ITO coating, in the middle the liquid crystal, and then the same thing again, ITO, glass, and polymer. So how to get it open so we can remove liquid crystal? And again, we tried many different things, and eventually a simple paper cutter will work, because the screen itself is only like 3 millimeters, something like that. And you cut it open, okay, and then you can separate. It's not that difficult. And to remove liquid crystal, we tried different solvents. So methanol, acetone, toluene, and hexane. And except acetone, okay, all the other solvents could work. If you put acetone there, we got some jelly stuff sticking to the glass, and it's difficult to remove. Maybe, okay, acetone is too strong, too reactive. Okay, and then likely, okay, from environmental perspective, you may just pick ethanol, right? Yeah. To remove the liquid crystal, and it's a really small amount, again, 20 to 30 grams per screen. Should we go further? Since we have already separate the top layer and bottom layer of your screen assembly, because we know this way you actually have exposed the ITO layer, the indium tin oxide layer. And originally we were thinking about maybe, since it's already opened, the surface area is quite large, we can try to recover indium. But then we did a quick calculation. Okay, so that's the indium price. And it used to be probably high back in 2006, 2007. And right now, okay, we are at about $550 per kilogram. And we did a quick calculation and then realized, well, the worth of indium per screen is only 2 or 3 cents. So it's not gold. Gold is much more expensive than indium. Maybe at today's price, still 100 times expensive, right? So 2 to 3 cents per screen, likely we cannot do it, right? And ITO is not that easy to break down. And likely you need to use some strong acid to dissolve it. So at that point, we decide, okay, we can separate the screen assembly and remove liquid crystal, but to recover indium is not profitable. And but the good thing is the screen assembly itself, the weight is not significant, right? And maybe we just store it somewhere, and later we hope the market condition will change. Maybe indium will become quite expensive, and then people can go back and try to extract indium from the waste glass. Okay. Okay. So in the lab, we built all the tools, and after some practice, okay, we run some time trials. And here is the result. So it can be done in about 4 minutes. And here is, okay, for each step, okay, the time needed. And to our surprise, we spent most time trying to open the case. Even with the cutter, not very efficient, because as right now, remember that tool, we only have one cutting edge, right? If you can put several cutting edge there, then okay, likely it will speed up the process, right? And so we believe after you do some optimization, you can shorten the disassembly time. And whether or not we can achieve 2.5 minutes, I don't know, but there is hope, right? So for the just the casing, okay, we spent close to 2 minutes, right? And there, likely you can save 1 minute, right? But the remaining step, likely the room for improvement may be quite limited. So that's for LCD monitors. How about LCD TVs? We did try several because it's kind of difficult to get used LCD TVs. They are not really showing up in large amount in the waste stream yet. Okay, we did try 2 or 3, and we found we can use similar approach, but we need to be very, very careful. remember we have quite a sturdy metal frame enclosing the backlight unit from the monitor. But in the TV case, that enclosure, that frame, is usually not made of metal and is actually quite fragile. So the protection is not there. So when you try to open, need to be very, very careful not breaking the light tube. And also the light tube, they have many, like 20, 30 of them, and they are really long if you have a large screen. Okay. So this is a very interesting project, right? And we think, okay, we can do some outreach activities. And one way is we have the team talk to other students, so seminar class, and Purdue has a Green Week in the fall term. Okay, that's another opportunity. Okay, they pick up, and also we contacted many recyclers and just try to gauge their need and get some feedback, and also some government agencies. Okay. And one recycler told us they have accumulated about 80,000 pounds of screen assembly in their warehouse, and they don't know how to do it. So this actually is an EPA P3 project, and you all heard about EPA P3, right? So it's National Sustainable Design Exploitation. Every year, teams will go to Washington, D.C. and compete. It's around the Earth Day time, so April 20th. And that's the team. And 2 semesters project. So we started fall 2012. And this was this spring, April. And we have 7 students, so 3 from mechanical engineering, and 2 from environmental ecology engineering, and 1 from material science engineering, and 1 from management. And the management guy we brought in just for, say, cost analysis, and also this guy. The first time we met him, he talked about, okay, at the competition, I can give an elevator pitch, real side of the project. But we got honorable mention, so we didn't make to phase 2. So if anybody is interested in pursuing further, okay, just send me an email. I can provide you the report and pictures and videos, and also the prototype tools. Okay. So one question the team got asked at the competition is, okay, could your tools handle Apple products? And we didn't really try our tools on Apple products. So the students, they were quite honest. They said, probably not. And likely that's true, right? Because Apple products, they are really not designed for disassembly, right? And due to some reason, they decide to use glue or adhesive to put things together, right? It's difficult. So actually, to make the recycler's life easier, likely you want to change the design, right? And actually, after we took apart monitors and TVs, and we tried to contact several manufacturers and say, okay, will you guys change your design so the light tubes are relatively easy to access? And they told us, like, well, we are working on OLED, the next generation. We don't care about the old product. And here is my favorite. Okay, again, I got this story from a recycler, and I called it a tale of 2 printers. And lifetime size, that's a pretty old printer, maybe back in 90s, right? And this one is new, nice looking and fancy, right? And but the recyclers, they hate this kind of printer. The reason, for the old one, okay, basically you can separate metal piece and plastic piece. But for the new one, back to middle of like early 2000 or something, they decide to change to this insert molding process. So metal and plastic, they are molded together. The only way to separate is throw the printer into a big shredder and cut into pieces. And even that, you don't have 100% separation, right? So by using insert molding, as you can see here, the claim is that will reduce the cost of the production and waste. That's true, right? But for recyclers, they cannot make money. To make it worse, the printer manufacturers, I won't name the company, but usually they are doing something like this. So every month, okay, they have open bidding process, and most time in Southeast Asia and China, like every month they run bidding, and after that, whoever wins the bid, they will ship the tooling site to the facility. So in order to save production costs, make money, those contractors, okay, they just use recycled mixed plastics and add a small amount of virgin material. And the result is for the recycler, okay, after threading, they got plastics, right? But that plastics actually is a mix. If they want to dispose, they have to pay money, because only some specific power plants or boilers with powerful water scrubber can take the mixed plastics and burn it for energy. And the common boiler or power plant cannot do it. Otherwise, you have dioxin and some other nasty stuff coming out. So, but on the printer manufacturing side, you know, those companies, they make money by selling the ink, the cartridge, not by selling the printer, right? They want to control the cost of making a printer, right? That's their business model. Do they know how to design a better printer from environmental perspective? Sure, they do know, right? But they don't want to do it. They decide to go this way. So talking about electronics, it's not just a technical issue, right? And that's why at Purdue, we started this pilot last year. And we have 15 faculty involved in this project, and also 5 other people from Tuskegee University. So people from engineering and social science, management, and all involved trying to solve this puzzle, right? And as you can see in the printer case, it's not like we don't know how to design a green and environmental friendly product, right? There's a business model involved, and different stakeholders, they have different interests, right? How to balance, and should we introduce some policy driver in order to change stakeholders' behavior? Also, as consumers, we really need to buy the most advanced products all the time. Do we really need to replace our cell phones every 6 months? And I'm still using my old 2003 LCD monitor, and it's still working, but it's small. And my LCD TV, okay, is 6 years old now. I expect, okay, that could last at least another 3-4 years, but the 3D TV is coming out, right? And at some point, I don't know. I have kids, and at some point they may say, that 3D TV thing is really cool, and let's catch one. So again, this EPA P3 project, we got some money from EPA, and also to support the teams travel to Washington, D.C. We got money from mechanical engineering department, and also the division of environmental and process engineering. And we also got some support from like 2 researchers. That's all. Thank you very much.
We can now take some questions from the audience here first. If you have questions. Jim?
Thank you. The state laws that have required manufacturers to accept a certain amount of their products back, is that changing their mindset in manufacturing?
Right now, basically, they pay recyclers for collecting electronic waste. I think the amount they pay is relatively small. Likely that will not lead to very significant change.
Are there other questions from anyone here? Bart?
Yes. Thanks for making the trip over today. I just have a question. Is there a company out there today that's doing a good job about moving away from planned obsolescence and instead focusing on reusable shells with interchangeable pieces for upgrades over time?
Okay, good question. If you do the so-called life cycle analysis on the electronic products, you will find out first, you consume lots of energy during use phase, right? Second, the most energy intensive components actually are those inside, say the circuit board and the chips. And just reuse the casing, certainly that will help, but only to limited content.
Other questions? Yes.
How realistic would it be to have the products recycled back to the companies and have them build disassembly lines in a similar fashion to the way that they are assembled?
Unless there's a government regulation saying they have to do it. Otherwise, likely they won't try it, right? Because it's money, and you need to build a reverse logistics, right, to collect all the products. Some companies actually are doing this. For printer cartridge, I believe HP right now is receiving. They don't care about the brand, you know, whatever cartridge you can send to HP. So, yeah, some companies are making progress, but large scale.
Anyone else? Yes.
What happens to the lights after you get them out? Is there anything useful that can be done with those, the backlights? Okay, now you got this tube of this basket of glass and mercury.
So basically, the current practice basically you just collect all the light tubes and send to some facility they can handle the hazardous waste.
So everyone keeps passing this thing down, just handing off.
Yeah, but it's really difficult to reuse. And if you break the light tube and try to do some chemical analysis, you will find, okay, about half of the mercury there already oxidized and deposited onto the side of the wall of the tube. And how to bring it back to life may be a way to do it, but cost-wise, it will be difficult.
Is there much of a market for mercury?
I don't believe so.
Yeah.
Do we have any questions from our viewers online?
Yeah, we have several.
Okay, so Beth is going to read these, and maybe you can repeat the questions.
Okay.
One of the viewers would like to see the slide with the survey reader website on it. If you could go back to that slide. The survey leader, it was at the beginning of the presentation.
Oh, you mean very beginning?
Yeah.
This one?
They had a website. It was like a. The next question is, why did you use an oscillating cutter blade?
So the question is why we use the oxidating cutter. The oxidating cutter has a safety advantage. So basically, the cutter is not attached to a sturdy or very solid axis. And so basically, if you push it really, really harder this way, okay, it will retract. So this way, we believe, okay, for safety perspective, people will not have their finger cut.
And future displays will mostly, maybe entirely be LED based. In the absence of mercury in lamps, will recycling industry go to shredding?
So the question is, if we all go to LED, okay, so maybe shredding becomes a viable option. Good question. I don't know. And but at least for the LED backlight LCD, several weeks ago I got an email from a researcher in Europe, and some LED backlight LCD TV in US, the light emitting unit contains cadmium, another heavy metal. So there's an issue there. And the products, models sold in Europe do not have that issue. For OLED, again, I cannot tell. So I don't know if there's some organics they use there could be carcinogenic or could be toxic. But good question.
Are the regulations in Europe different than the US that they don't use cadmium and it's used here?
Well, they have the WE standard. So basically, you cannot really use cadmium and also RoHS. Okay, RoHS. So in US, I don't believe. Okay, we have a strong enforcement on that. So I think that's why.
Is there any other questions?
Can you verify that it is cadmium in the LED lights? For the online viewers, they couldn't hear you.
Yeah, I just got an email from like a researcher in Europe, and she said, okay, for certain kind of LED lighting unit, okay, there is cadmium there. They are trying to build an inventory.
Joe, did you have a question?
With laptops, that's a different problem. I think more time to do, since you have a small sheet. You have to take the screen off of the keyboard. Maybe I'm
Yeah, we thought about laptops, and actually at the competition, one judge asked about tablets. They're smaller, and for the laptop, the screen is a little bit more difficult to open. Yeah, maybe we can write another EPA P3 proposal.
This is just for desktop and larger TVs, right?
Yeah.
Do you see that being a different market for that, for laptops?
Yeah, we have large amount of laptops. Eventually, we'll show up in the race rate, right? And try to figure out a way to do it.
Do you see the laptops going down as far as consumers? Now it seems like the phone is turning into a laptop. The smartphone is really kind of taking the place of the laptop. Do you see that? Is that a problem?
Yeah, smartphone and tablet.
Right.
Yeah,
That's really taking the place of laptops. So
yeah,
it's just,
that may present a new challenge.
at least there'll be less waste.
Okay.
But if you replace your tablet or cell phone very often, very frequently, then I don't know.
Beth has one other.
Yeah, one of our online viewers had a comment. It says that your presentation on the lack of concern of OEM for used equipment, but that their R&D are concentrated in the new generation of products seems to justify the need for making legally mandatory the use, the extended producer responsibility. And I say that likewise, in the case of recuperating Indium, as having a financial support could facilitate the recovery of Indium. Do you have any comments back?
The question is, okay, talking about OEMs and recyclers, and they all have different interests, right? And maybe extended producer responsibility with some government mandate may solve the problem. So the manufacturer will design better products, right? The reality is, even in Europe, okay, we have WEEE, right? And if you check that regulation, it doesn't really require the manufacturer to take care of their own products. They just need to hire a third-party recycler and have the recyclers to have report or data available. That's the reality. And in the future, if we do have some strong regulation, consumers will need to bear the cost, I assume.
Okay, we'll take one last question, Jim.
You mentioned that you contacted a manufacturer and tried to give them this intelligence for their use, and they said, we're not interested because we're on to the next generation. Did you find they had any interest in building in to their design of the next generation more friendly recycling technology?
Actually, we contact a major TV manufacturer, and at that time they told us they are moving to the LED backlight technology. So there's no mercury involved, and they believe they're good. But at that time, I didn't really know, okay, cadmium could be a potential issue.
We will thank you very much.
Thank you.